Chapter 9, Lesson 2, Transformations of Quadratic Equations, and Chapter 9, Lesson 3, Solving Quadratic Equations by Graphing. So these translation rules should already be in our notebook, and so hopefully you don't have to take them down again. And today we are doing So for our quadratics, our original equation of f of x equals x squared is a parabola shape that starts at the origin and is perfectly symmetrical on either side of the y-axis. So in this first one, I have g of x equals x plus 10, or 10 plus x, which I can change into x plus 10 because addition is commutative. And so this would fall under rule number 2, which says a number added or subtracted inside the parentheses shifts the equation right or left opposite the sign. So this would be shifted left 10. So I take my original one and shift it from the origin, 7, 8, 9, 10, and keep the symmetrical shape, but just shift it left 10. This next one follows the same process. I can change it to x squared minus 2/5. So this should be a downward shift of 2/5. So it would just go a little bit below the origin and still be the same symmetrical shape. This one says negative x squared plus 9. So this has two moves. The negative out front will flip it, and the plus 9 at the end will move it up 9. 2, 3, 4, 5, 6, 7, 8, 9. And flipped. On this one, the 2 out front would make it vertically stretched, and the add 2 at the back would move it up 2. Number 5 has three moves. It's a flip, a horizontal stretch, and down a half. So it would look something like that. So the horizontal stretch is going to make it look wider. So now on these last three, matching them to its graph, we're looking at the leading coefficient of all of these. A is the only one that has a negative out front. Then looking at the starting places of these two, this last one is shifted up 1, and this is down 1. So that's how I know B goes to 9 and C goes to 8. List the functions in order from the most vertically stretched to the least vertically stretched. So the most vertically stretched is going to have the largest leading coefficient. So this would be the most vertically stretched. This would be the middle, and that would be the least. On this word problem, we have two parachutists jumping from the same time from two different airplanes as part of an aerial show. The height of the first parachutist is modeled by this equation, and the height of the second one is by this equation. So basically what we have is one parachutist up in an airplane at 5,000 feet, and he's jumping out and going to the ground, and a second airplane at 4,000 feet, jumping out of the ground. So the change in between them is 1,000 feet. Which parachutist will reach the ground first? Parachutist 2. Okay. To solve a quadratic, what we are doing to solve them is we are finding their x-intercepts. So basically, we're going to have three different types of problems. The first is going to be the most common, having two solutions or two x-intercepts. The next most likely common one is where it only touches once, so it has one x-intercept. And the last is if it's a floating one, it would have no solution or no intercepts. So using what we learned yesterday, the first thing we're going to do for number 1 is find the axis of symmetry. So I'm going to do the opposite of B over 2 times A would give me 2.5. Then to find the vertex, I'm going to sub 2.5 back into my equation. And I get negative 2.25. So my vertex is just below the axis there. Then in order to find my y-intercept, I'm going to cover the x, and that would give me a y-intercept of 6. Mirroring that point across my invisible axis of symmetry gives me this shape of the parabola here. So I need to make a guess at my x-intercepts, and I think they are 2, 0, and 3, 0. On number 2, again, I'm going to start with finding the axis of symmetry, opposite of b over 2 times a, which would give me negative 3. Subbing that back in to find the vertex. So I'll do negative 3 squared plus 6 times negative 3 plus 9 gives me 0. And since I know this one is going to open up, I know that this only has one x-intercept. It's at negative 3, 0. On this last one, when I do the opposite of b over 2 times a, it gives me 1.5. And when I sub that back in, I get 1.75. My intercept I know is 4. Mirror that across, and this one has no solution or no x-intercepts. Okay, on this one we have the function negative 1 over 25 x squared plus 9x. And in order to find the axis of symmetry, there is no b term. So I'm going to do 0 over 2 times negative 1/25, which is 0. Sub 0 back into my equation, and I get 9. And I know that this one is going to open down because of the negative out front. And so in order to find my intercepts, I'm actually going to look at it on my graphing calculator. So I have negative 1/25 x squared plus 9. And I find that my intercepts are negative 15 and positive 15. For part B. And part C says, what is the length of the walkway between the points where the support intersects the hallway? The walkway. So I got to figure out what is the length from here to here. And the intercept was actually moved when we looked at it. And so it's 15 feet.